Hi everyone. Today I'll be covering derivative using quotient rule. So let's say we have a quotient or fraction u over v. So the way quotient rule works is that we take first the derivative of u. So we say u prime multiplied by v and then minus u multiplied by the derivative of the v or v prime all over the square of v. Okay. So u prime times v minus u times v prime over v squared. So let's go ahead and apply this formula or quotient rule by this set of example. Okay. So let's say example number one. Say y is equal to 2x over 3. Now this is a fraction. Okay. This is a fraction looking expression. So you can use the quotient rule. But from our discussion of the power rule, let's recall that. Let's say you have y is equal to, say, 2x plus 3. Now, to get the derivative of this x term, that x raised to the first power, the derivative of that 2x is simply the coefficient 2. And what's happening with this x to the first, it's just going to go away because, when you use the power rule, when you multiply this 1 by 2, that's going to give you 2. And then times x to the 1 minus 1, so that becomes a 0. And then plus the derivative of constant, again, is 0. I'm going to go ahead and write it down so you can see what's happening. So the y prime equals, now this x to the 0 is just going to be 1. So you can see that when you have a constant 2 next to the variable x, which is understood to be raised to the first power, its derivative is simply the numerical coefficient 2, okay, in this case. And again, this is constant. Its derivative is always 0. The variable x, okay, one more important thing. If the variable x is a numerator, then go ahead and you can use the power rule. Just like in this example, although this is a fraction, but our variable x is a numerator and our denominator is just a constant 3. So you can also clearly see that if I, set this 2/3 apart times the x. So you can see that 2/3 is like a coefficient of x, meaning its derivative is just 2 over 3. Okay? Now, say, can I use the quotient rule for that? Because that's a quotient or that's a fraction. You may, but you really don't have to use the quotient rule because this is quite tedious to use, compared to this one single step process, from our power rule. So let's say you want to use the quotient rule. So we assign this to be our u. The 3 is going to be the v, okay? So the quotient rule says that take the u prime multiplied by v minus u times the v prime over v squared, okay? So let's follow this quotient rule. Says u prime, so that's derivative of 2x, which is 2, times the v, which is 3, minus u, which is 2x. Okay, and then v prime, the derivative of this 3 is 0. Okay, so this part of the process is just going to be 0 over v squared. So the v is 3, square that. So the derivative is 6 over 9 or 2/3 when reduced. Okay, so you can see that it's the same answer that we got using that power rule. All right, so for number 2, so what happened if I turn it upside down? Instead of 2x over 3, we have this 3 over 2x. Again, this is a fraction or this is a quotient, and you can use the quotient rule for this, or is there any shortcut? Yes. Now, notice that this x is now part of the denominator and we have a constant numerator. Okay, so if you remember from my previous video about reciprocal rule, all right, that we have a shortcut in case we see something like 3 over 2x, which is a reciprocal. So we're going to call it the reciprocal rule. And the rule says to get the derivative, this is a shortcut. So what we do is multiply this constant numerator to the exponent of your x, which is 3 times 1 is going to be 3, divided by, all right, you don't have to do anything with this 2. Write it down here, multiplied by x. So what you're going to do with this x is you're going to raise it to 1. That's his exponent, but you have to add 1. So that becomes a 2. Okay. And one last step, make sure you switch the sign. So from positive, its derivative is negative. So that's what we call the shortcut or the reciprocal rule shortcut. So it's negative 3 over 2x squared. Okay. What happened if you use the quotient rule for that? Okay, so we can compare, how it's done against this reciprocal rule shortcut. So we go ahead and use the quotient rule for this. U prime v minus u v prime all over b squared. So your y prime is equal to what? U prime, which is the derivative of the numerator, which is 0, multiplied by v. Now the v is 2x, okay? Minus u, your numerator 3, times v prime. Okay, v prime is the derivative of your denominator, which is now 2 over v squared. So that's 2x squared. Now this is gonna be 0, so your y prime will just be this negative 6 over the square of 2x is 4x squared. Now reduce this, it's gonna give us negative 3 over 2x squared. Okay, you can see how it's more efficient to use the reciprocal rule shortcut. Okay, take number 3. So number 3 is similar to number 1. Okay, so I want to emphasize that when the variable x appears on top, it would be best to just use the power rule. Okay, so 3 times 2, okay, over 7. This x now raised to 3 minus 1, which is 2. So your y prime is equal to 6 over 7 x squared. Variable x is on top. Okay, so just use the power rule. Now if I switch it, I make it like 7 over 2x cubed. Now, your numerator is constant. Okay, so this is a constant. This is similar to our example number 2. And then you have your variable x in the denominator. Okay, so this is your denominator over here. And that makes this what? That makes this a reciprocal. Because it's a reciprocal, you can use the reciprocal rule shortcut. Okay, you can use the reciprocal rule shortcut. Again, let's see if you remember that. So your y prime is equal to what? Multiply 7 times 3. So that's 21 over, okay, so copy that, a constant 2 multiplied by x. So you're not going to do anything with this 2 over here. X raised to 3 plus 1, so becomes a 4. And last step is switch the sign, so it's going to be negative. So y prime is going to be negative 21 over 2 x to the 4th. Okay, so this is using the reciprocal rule. Now for number 4, I can show you the quotient rule. Okay, one more time, so just to make sure that sometimes if there's a shortcut, you just go ahead and use it rather than use this quotient rule. Sometimes it gets annoying, it's too long. Okay, So let me show you how to use the quotient rule for this example. Okay, so 7 over 2x cubed. So that's our y. Or, sorry, y equals 7 over 2x cubed. So this is your u, that's the v. Okay, so y prime quotient rule. So this is quotient rule. So u prime times v minus u times v prime all over v squared. So your y prime will be u prime, that's the derivative of your 7, your numerator, which is 0, times v times the 2x cubed, okay, minus u, which is 7, times v prime, which is 6x squared, by power rule, all over v squared. So all over 2x cubed squared, right? Simplifying, so this becomes 0. That's negative 42x squared all over 4x6. Now, 42 over 4 will be reduced to negative 21 over 2. And then this part over here, x squared over x6, is going to give us this over x to the 4th. Okay, so this is exactly what we got using the reciprocal rule shortcut. Okay, let's look at number 5. Say we have y equals x squared over 3 to the 4th. Okay, now when we have this quantity raised to another exponent, it would be best to rename this using algebra, okay, rather than use chain rule. So what I mean is raise x squared over 3 by 4, and that's going to give you what? So these two exponents, 2 and 4, is going to give you 8 when multiplied. Now take note that this 3 is also raised to 1. So when you multiply this 4 to that one, that's going to give you 3 to the 4th. So your y is now renamed to what? X to the 8 over 81. Now, the variable x is on top. You can just use power rule for this, okay? So that's 8 times x to the 7 over 81. And there you go. That's the derivative. What happened if I switch it? Let's turn it upside down. Let's say you have instead 3 over x squared raised to the 4th power. Okay, so first thing we do is rename it using algebra. Sorry, this is not yet the derivative, okay? This is just the renaming part. So the 3 to the 4th, again, is 81 over x squared to the 4th is x to the 8. Now that makes it a reciprocal. Because it's a reciprocal, you can use the reciprocal rule, okay? Shortcut to find its derivative. So what is 81 times 8? That is 648 over x to the 8 plus 1. So that's x to the 9. And then you switch the sign, okay? So that's how easy the reciprocal rule shortcut is. Let's look at number 7. Say y is equal to 9x to the negative 2. Now this is equivalent to 9 over x squared, okay? Now let's compare the process of differentiating the 9x to the negative 2 using the power rule. So we say negative 2 times 9, okay? So that's the power rule right here. I'm using the power rule. Negative 2 times 9, x to the negative 2 minus 1, okay? So that is negative 18, x to the negative 3. If you want to rename it, you can move this x to the negative 3 down here and then switch the sign of the negative 3, okay? So you can use the power rule, or if you move this x to the negative 2 from the start, and then recognize this to be like a reciprocal, say this is a reciprocal, then you can use the reciprocal rule shortcut, okay? Reciprocal rule shortcut or trick, okay? And that is what? Your y prime will be 9 times 2, which is 18, over x to the 2 plus 1, 3, and then switch the sign, okay? So the reciprocal rule is still shorter after you move this x to the negative 2 down from the beginning, okay? Let's look at number 8. Say you have y is equal to 3 over 7 x to the 4th. So once again, this is a what? This is a reciprocal, okay, with a fraction 3 over 7. So our reciprocal rule applies here. Constant numerator, variable x, raised to some exponent in the denominator. So you can go ahead and use the reciprocal rule shortcut. That means 3 times 4 is what? 12 over 7 times x to the 4 plus 1, 5. And then you switch the sign. Okay? That's how easy the reciprocal rule is. Let's look at number 9. Say y is 3 over 7x to the negative 4. Okay, so I'll show you two ways to do this one. So one way, so this is like an or. So one way I can rename that by moving this x to the negative 4 on top. If I move this x to the negative 4 on top, the negative 4 becomes positive. Now, your variable x is now a numerator, so we can just use the power rule, okay? So that means 4 times 3, and then x to the third. 4 minus 1 is 3 over 7. So your y prime will be what? 12 x cubed over 7. Now, say, can I use the reciprocal rule for that? Yes. So you have this negative exponent, and say, okay, I don't want to move that x to the negative 4. Instead, I'll use the reciprocal rule, okay? So if your variable x is raised to a negative exponent, and that is originally downstairs, so let's see which one is better, okay? So y prime using the reciprocal rule is, okay, let me write this, 3 over 7 to the negative, 7x to the negative 4 here. So 3 times negative 4 is negative 12 over that 7x. Okay, negative 4. Remember, using the reciprocal, you add 1 to that exponent. Now, this is negative 4, so you still have to add 1. So negative 4 plus 1 is negative 3. And don't forget to switch the sign, okay? So we have to switch the sign from the positive original sign now to a negative. Okay, let's simplify. Looks like this is more complicated because of the negatives. So we have two negatives here that's going to turn into positive 12 over 7x to the negative 3. Now when you move this up, okay, so that's 12x cubed over 7. All right, so you can compare. Looks like the first method is shorter. Okay, so more or less in here is if you have a variable x raised to a negative and originally part of the denominator, you can go ahead and move it up so that you can use the power rule and make it easy, okay? Rather than use the reciprocal rule. Let's see number 10. Y is 3 over 5x plus 2. Okay, so this is a quotient or fraction And we have a binomial denominator, okay? So we cannot consider this a reciprocal because of this plus 2 that's added to your 5x. So we really have to clearly use the quotient rule for this. This is your u, and this is the v, okay? So our derivative using quotient rule says we have to take the u prime times v minus u times v prime over the square of v, okay? So what is u prime? U prime is 0 multiplied by v, which is your 5x plus 2, minus u, which is 3, multiplied by v prime, the derivative of 5x plus 2 is 5, all over the square of v, which is 5x plus 2 squared, okay? All we need right now is to simplify the top, so this is just going to be 0. So we have negative 15 over 5x plus 2 squared. Now, if you want to use the quotient rule, sorry, the chain rule, you may. So that's another option, okay? So let's say you want to move the 5x plus 2 on top, okay? So this is your 5x plus 2. If I enclose it, it means it's raised to the 1. Now you can move it on top. That makes 3 times 5x plus 2. That 5x plus 2 quantity now raised to a negative 1. This is constant 3, okay? So because this is not a plain x, inside this parenthesis is not a plain x, we cannot simply use the power rule for this. We have to use the chain rule. So by the chain rule, says y prime is going to be like a, chain rule is like a power rule with one extra step. So first step is use the power rule. That means multiply negative 1 and 3. So that's going to give you negative 3. Now copy that base 5x plus 2 raised to the negative 1 minus 1, which is now negative 2. To make it a chain, that one extra step is to get the derivative of this 5x plus 2, which is 5, and you multiply that by this first expression that we got earlier. And now when simplifying, this is what? Negative 15 times 5x plus 2 raised to the negative 2. Or if you want to move this 5x plus 2 to the negative 2 downstairs, it's going to give you this same answer that we got using the quotient rule, okay? So hopefully you learned something about the quotient rule by showing you this first set of examples. This is kind of like the easiest. And I appreciate you for listening, and I'll see you again for the next part of this quotient rule series, okay? So thank you for watching.